y equals sine of theta is a function that you can graph on the coordinate plane. So if you think about the unit circle, I'll draw a unit circle over here. When theta, and we'll talk about theta being in radians, is 0, the y value is 0. When theta, which we'll do pi over 2, because pi over 2 is 90 degrees, is pi over 2, the y value is 1. Right here is pi, because it's 180 degrees. The y value is 0. Right here is 3 pi over 2. The y value is -1. And then right here, this is 2 pi. The y value is 0. And then this is going to be 5 pi over 2. The y value is 1. And then we have 6 pi over 2, which is 3 pi. The y value is 0. So you can kind of see that I can complete this pattern 0, 1, 0, -1, 0, 1, 0, -1. That's where you're getting a periodic function. So I'm just going to graph this function right here. So at 0, 0, oops, didn't put that in very good. So 0, 0 is a point. Pi over 2, 1 is a point. Pi is a point. 3 pi over 2, -1. 2 pi, 1, 0. So you're having this cycle right here. The same thing happens when if you went negative. If you went negative pi over 2, okay, the y value would be at -1. So here I am finishing it. So if you have y equals a times sine of b theta, where b is greater than 0 and theta is in radians, a is the amplitude of the function. So if a is the amplitude, it's actually going to be the absolute value of a is the amplitude, because amplitude is always positive. So in this case, y equals sine of x. The number in front, a, is 1. So that's why down here the amplitude is 1. You're going up 1, down 1. The height of the wave is 2, and amplitude's half the height. A will also determine whether or not the function has been reflected across the x-axis. B is the number of cycles in the interval from 0 to 2 pi. So if I isolate 0 to 2 pi right here, there's one cycle. The cycle has a maximum and a minimum. Okay, it goes 0, max, 0, min, 0. And the period of the function is 2 pi divided by b. So remember that b is going to be the coefficient of this. So here the b is 1, so the period is 2 pi divided by 1, which we can see right here is 2 pi. So let's look at these different graphs here. So what's going on with number 1 is it looks like we have this amplitude that has been stretched out. It's a vertical stretch compared to the other one that we just did. So the amplitude is 4. In the period, what I want to do is I can go from max to max right here. So it's half pi to 2.5 pi, or I can go from here to here. So the period is going to be 2 pi. So the period is 2 pi. So then what is our b? So our b, remember, the period equals 2 pi over b. That's our formula. So if I take my period, which is 2 pi, I'm going to do 2 pi equals 2 pi over b. Solving for b, multiplying both sides by b, I'm going to get b is 1. So b is 1. So has it been reflected? Now, to see if it's been reflected in a sine function, and think about the unit circle, the y value increases as you go around the unit circle to start in the first quadrant. So if it goes 0, max, 0, this is a positive sine function. So it has not been reflected. If it started at 0 and went down, then it would be a negative function. So I'm going to write that it has not been reflected. And then, so now I can use my equation. So my equation is going to be y equals 4, because that's my a value, and it's going to be positive 4, sine of bx, and my b is 1, so it's just going to be y equals 4 sine of x. Okay, number 2. Gonna maybe zoom in a little bit. So if I look, my amplitude is going to be 1.5, because it's going from negative 1.5 to 1.5, so my amplitude's 1.5, or 3/2. The period, this one's kind of harder to see, but I'm going to go from here to here, because within this part it has a maximum and a minimum. And so if pi is right here and my period's going from here to here, this is a cycle. So if pi, this is half of pi, so this is going to be pi over 2. That's my period. So my b is going to be, remember the formula, period equals 2 pi over b. So pi over 2 equals 2 pi over b. You can either cross multiply, or I can see that this is half a pi, so in order for this to be the same ratio, the pi's would cancel out. This would have to be a 4. So my b value is 4. And then has it been reflected? So we're going 0, max, 0, min, 0. It's going up. So this has been not reflected. So no. So that makes it so the a value is going to be positive. So this is positive 3/2 sine, and then my b value is 4, so it's 4x. Okay, one more over here. The amplitude is going from -2 to 2, so that's 4, so half of that is 2. The period is going from 0 to between 2 pi and 4 pi is 3 pi. So the period's 3 pi. So to find my b, I'm going to do period equals 2 pi over b. So 3 pi equals 2 pi over b. Multiplying both sides by b is b 3 pi equals 2 pi. And then dividing both sides by 3 pi. So the pi's will cancel out. So b is 2/3. So has it been reflected? So if it's been reflected, see how it's going 0, min, 0, max. Okay, I'm going to contrast that with the one previous. This one went 0, max, 0, min, 0. And just look over here again. This one goes 0, min, 0, max. So this has been reflected. So yes, it's been reflected. So if it's been reflected, that means your a value is going to be negative. Your amplitude is going to be negative. Or not your amplitude is negative, your a value is negative. So your amplitude is always positive, but the a value is based on the amplitude and whether it's been reflected or not. So it's going to be -2 sine of 2/3 x.